Okay, today's lesson is on Trig modeling. You're not going to really need everything that's up here. The ones that we've really been paying attention to was if you're doing a sinusoidal or wave and cosine, which is also a form of a sinusoidal wave. The period we've been doing to find the b value, we've been taking the old period, remember, and dividing by the new period to get our b value for our equation when we're writing the equation. If we basically this is the one we've been using. Does anybody care that I don't use 2 pi divided by b and then set it equal to the period and then solve it? You know, if you find that you want me to do that or show it again that way, I would be happy to do so during the lesson. But we are used to doing this one. At least that's what I thought you were used to. The frequency, don't worry about that so much, but frequency just means how often is the wave occurring over the time period that's given, okay? Now, you will want to know how to find the maximum, the a value. That's when you take and subtract the max and the min, and you divide by 2. And your k value, which is your center line. A lot of books write your center line as an equation, which it should be. It is a horizontal line. So the center line is the y equals k. The equations, sometimes some books put the k at the back, you know, at the end of the problem or the end of the equation. Some put them in the front. Ours had been had it in the front for a while, and then we saw sometimes it was in the back, but it should be outside of the parentheses, of course. It's not a phase shift. All right, we're going to write a sinusoidal function, sine, with a maximum point at A and a minimum point at B. Now, if A is the max and B is the min, is that where the wave actually starts? Think about what that means. Doesn't this mean the highest point? High point? Okay, so if that's a max, then that's happening at pi. It's not happening at 0, and the sine wave starts at 0. So that means we need to find our first maximum point at pi 8. So let's make 8 be the max. Pi 8 is where A is located. Well, a sinusoidal wave starts at 0, 0, and let's see what they've given us. They put a min point, which is going to be down here somewhere. All right, so I just noticed here that this is the y value is your max and min values that we're talking about vertically. The y is 8 and negative 8. So if we do 8 plus negative 8 divided by 2, that's going to give us our k. And that would be 0 divided by 2, which of course is 0. All right, so we do know the center line's at 0, and that's where we label our x-axis. Let's see what the amplitude is. A is when you subtract the max and the min, 8 minus negative 8 divided by 2, and that's going to be 16 divided by 2, which of course is 8. All right, so that means we're going up to 8 and down to negative 8, so that means that minimum point, negative 8, you might have been able to tell that already. So I didn't have to do all that work. You've kind of intuitively looked and seen max to min, there's your amplitude. Halfway between there would be 0. Excuse me. All right, so if 3 pi is at 3 pi negative 8 that the min's occurring, this scale must be 1 pi, 2 pi, and then 3 pi. And that's at 3 pi negative 8 we reach the minimum point where B is. So in between there, this is what it was doing. It was coming to its center line at 2 pi, 0, and then down to negative 8. So if I wanted to continue one full cycle, I would back it up to the 0. And I'm only changing color to show you that what they actually gave us were these 2 points. And where will we be ending? At 4 pi. All right, so that now we've determined what our period is. The period is 4 pi. To find the b value we need in our equation, we take the old period or the period of the sine wave without any stretch and take 2 pi and divide it by 4 pi and reduce that, and we get 1/2 for the b value. So now we're ready to write our equation. We got the center line is 0, so I don't have to write anything in for k. Y equals an amplitude is 8 sine, b is 1/2, and that multiplies times x. You can put x in the parentheses or not. Okay, let's try another one of those. Anybody still need this before I turn? Okay. Good. All right. So now the next one, we've got a max at 2, 1. So that's, and a min 6 pi negative 3. So let's find our center line and our amplitude, etc. So k is equal to, which is the center line. We're going to do our max minus our min divided by 2, which gives me 4 divided by 2, and that's 2. Okay, so my center line's at 2, and what's my amplitude? 1. I'm sorry, I did that backwards, didn't I? Pardon me. That's your A. No, I'm sorry, I gotta flop those. I subtract to get my amplitude. I add to get my center line. I'm a little distracted today. Little family stuff going on. I need to try to keep out of my mind. Okay, so 1 plus negative 3 divided by 2 would give me negative 2 divided by 2, which is negative 1. All right, so y equals negative 1 is your center line. Now, if your center line's at negative 1, I am going to put 0 on the x-axis. That's where I want to label things. So from there, I have to go down 1, and the amplitude was 2. So up 2 from there would put us at positive 1 for the high point, which is what they said the max is at. And that occurred at 2 pi. So there's your A, 2 pi 1. And then the center line has to go below your center line for the min, which is at negative 3 anyway. They said so. I might just extend this just to even it out. Okay. So our x scale is, I don't know why I put an equal sign there, is 2 pi. So let's continue counting by 2 pi's. 2 pi, then would be 4 pi, 6 pi, 8 pi. Our min occurs at 6 pi negative 3. And our center line is here. If you like to draw that little dashed line in to help you graph it well. Okay, so we're coming up here. We're hitting at, our center line right there at 4 pi negative 1. Then at 6 pi negative 3, we're finally at that b value. And again, I'm just extending it from the min and the max to get the full cycle. All right, so our k value, if we want to put it first, I don't really care if you like doing that because that's what you're used to. It's fine with me. Or it can be at the back. Negative 1, the k value center line, plus amplitude was 2. This is a sine wave. And the b value was, we didn't figure that out yet. So the period here is what, guys? The period is 8 pi. Okay, so b is 2 pi divided by 8 pi. 1/4. You were right, Anthony. 1/4 x. Next, we're going to be doing some applications. Okay, so we're going to have to think about what can we do to find out what they're asking us to find out. The displacement, D, in feet, of a boat water line above sea level as it moves over waves can be modeled by D equals 2 sine 2 pi t, where t is time in seconds. Now that's going to be your x-axis. And sometimes it's good to remind yourself that your time is in that certain amount. It's in seconds or minutes or hours. Graph the height of the boat over a 3-second interval. Okay, so it says that this is the equation. We're going to use that to get our graph. I see an A value of 2, so our amplitude is 2. I see a B value of 2 pi, which means the period is 2 pi divided by 2 pi would be 1. If the period's 1, one cycle occurs over 1 second. How many are we going to graph? It said to graph over a 3-second interval. So we need 3 cycles. If this is seconds, and that's 1, I'll split it up into thirds. See, so that's my 0. It said amplitude's 2, so if we're going from 0, we're going up to 2, down to -2. But 1 cycle is occurring. I don't like how big I made my slashes. They're so humongous. Make it a little smaller. I'm going to cut that up into quarters. So this would be 1/2, 1/4, and 3/4. All right, let's see. We're going to graph a sine wave, so that means we're going to be starting at 0, 0. We'll be going up to 1/4, 2, back to the center line, 0, 1/2, 0. Then at 3/4 seconds, we're at -2. And at 1 second, we're back to the center line, 0. All right, so there's 1 cycle. We're going to graph it 3 cycles, so I'm just going to chop this up, and I'm not going to keep labeling, you guys. That's okay if we don't. I mean, I could. We're just going to X scale of a 1/4. And I'm starting to not graph as beautifully here. That's okay. You got some athletes heading out. Good luck. Who are you against tonight? Who? Oh, try meet. Well, good luck, ladies. You're welcome. All right. What is the time when the height of the boat reaches a maximum of for the second time? The first time was right here. The second time would be right here. So we're finding out what this time is. So if our interval was a quarter, this would be 1 quarter, 2 quarters, 3 quarters, 4 quarters, 5 quarters, 1 and 1/4. Okay? So 1 and 1/4 seconds. Does anybody still need this page? Okay, next problem. The height of the water in a bay varies sinusoidally over time. On a certain day off the coast of Maine, a high tide of 10 feet occurred at 5 a.m. Well, let's write that down as a point. 5 a.m. Well, maybe we should think about how far apart these are here. 5 a.m. is 5 hours after midnight, right? So that's the beginning of the day. So if we decide to let my x-axis here, if that's going to be 0, 5 a.m. is the x value. 5 hours have passed since midnight, and the maximum height is 10. So let's do it time versus feet. We wouldn't put time vertically. We're thinking about how high the water goes. That's going to be our y value. What's the other point? It had a low tide. So this is my h, high tide. Low tide would be it happened at 3 p.m. How many hours have passed since midnight at 3 p.m.? Okay, got you, since midnight. Wait a minute, let's just think about the low tide. Yeah, so since 3 p.m., okay, I know these are 10 hours apart. Anthony, you were going for the distance between these two, how far apart these are. So you're right about so you guys are both coming up with good things. It's just not the same thing. So we want to make sure we know what we're speaking of. If we're talking about where this point is located, 3 p.m. is 12 plus 3 hours after midnight. So the point is actually 15:02. Okay, you with me now? Right? All right. Now, what you were thinking of is how far apart are these times? So half a wave, half a cycle is occurring going from the max to the min in 10 hours. So that means if this is from here to here is 10 hours, then a full cycle or the period would be how many hours? Guys, max to min is only half the cycle. All right, I see the confusion here. All right, guys, we got to think about how to label an x-axis. All right, and if 0 is midnight, I'm not going out 24 hours. All right, I want to see when it begins and when it ends. All right, the cycle at 5:10, it's hitting its max. At 5 a.m., 5 hours after midnight. All right, that just happens to be a point. How long has passed from 5 to 15 hours? That's 10 hours, but it's only half of the cycle. So how long is a full cycle? All right, 20. The period is 20. Now, I know somebody said 20, but I'm sorry, too many people were saying 10. All right, are we okay now? All right, the period is 20. All right, so let's go out to the end here. We're going to graph one period. T is the number of hours since midnight. So let's go halfway would be 10. Half of that's 5. And then we have a scale of 5. Our x scale is 5 hours. 5, 10, 15. Okay, now it's sinusoidal. So yeah, we're going to do a sine wave. But let's think about the numbers on the vertical axis now. All right, it goes from a height of 10 to 2. 10 plus 2 divided by 2 is 6. 10 minus 2, or the difference in them, divided by 2 is 8 divided by 2, which is 4. Okay, now, which is which? One is the center line, one is the amplitude. 6 is the amp. Okay, and the center line is 4. Okay, this is, what number are we on? Number 4. Okay. Now I just did that backwards again. Okay, it's not my day. Okay, I have the numbers right, and but I listened to someone say A, and I was about to say this is the K, and this is your amplitude A. All right, center line is at 6. Let's just I'm going to make this extend a little bit. I'll put a 6 there. We're going up to 10 because that's our max, and 2 is our min. Okay, so 5, 10, we'll put a point. We know we're coming from the center line, which will be at 0, 6. We'll come back to the center line, down to 2, and then back to the center line. Now we're going to go ahead and write our equation finally. Our amp was 4, so it's y, and our center line was 6. We're going to have 6 plus 4 sine. Now we got a period of 20, so we're going to have to take 2 pi divided by 20. Yeah, pi over 10 for our b value. Pi over 10 times x. It says use your equation to predict the height. Well, that would mean that they want us to plug something in. So if it's 2 p.m., how many hours after midnight is 2 p.m.? Okay, 14. Yes, Madison. Time is 14 hours. We're going to plug in 14 into our equation. Try it. I have a reason that I'm telling you to try it. Strange. My calculator was working last hour. There we go. Okay, so what are we typing in? 6 plus 4 sine pi divided by 10. Now, I'm going to tell you what, I'm going to have a different answer than you. Is anybody getting 14? What, or tell me what your calculator's giving you. Somebody's giving 2.2? Well, what's wrong with mine? Pi times, I sure didn't mean to put an x. So what I'm going to put in, I don't know why I put x. I'm going to put a 14 in there. I meant to hit times 14. If you're getting 2.2, it's right. Now let's think about it. I'm trying to get you guys to think about what you need to do. What kind of equation is this? Are you in degrees or are you in radians? You have to plug something in your equation, you got to put it in radians. You go to your mode button. What? I'm pressing it right now. Mode, and then yes, arrow down to where it says radians. That's the only time we've needed to be in radians so far in this whole unit. Okay? We have not needed to be in radians any other time. All right, then remember, theta does have to be in radians for a lot of our formulas. Okay, everybody able to get that calculation? Because there's just one more that we're going to do that has to have it in radians. So it's 2.2 feet. Could you kind of tell it was a little more than 2.2 just by your graph? Look where 14 hours would be right around here. It wasn't quite down to the bottom of 2. That's a reasonable answer. Do you see why 6 is not? That was implying it was up here. Your graph does not show it at 14 hours up here, does it? Okay. Paddle wheel of the SS Brogan was 13 feet in diameter. Okay, guys, I know it's late. Let's think about what these things are saying, though. What's this going to be? Does anybody know what I had some kids ask me what a paddle wheel was last hour. What a paddle wheel was. Now, I know it's part of history, but there's still some around in places. Yeah, it's a boat project. It moves through the water by its ginormous paddle wheel-like thing. You ever heard good studies about the Mississippi River? Yeah. Okay, Tom Sawyer. Oh, never mind. All right. So anyway, the paddle wheel of the SS program was, they used to have some of these. No, it sounds like well, I don't know what the SS program was, but I guess somebody could look it up. Yeah. I didn't say you, though. All right. The paddle wheel is 13 feet in diameter. Okay, and it revolves 30 times per minute when moving at top speed. All right, using this speed and starting from a point at the very top of the wheel. We're going to start at the top of the wheel. Write a model for the height and feet of the end of a paddle relative to the water's surface. Okay, so let's make the surface of the water 0 as a function in time t. Now, this is going to be time, and it's going to be in minutes. At least that's the way it's reading. Not that we couldn't convert it, but let's not. Assume the paddle is 2 feet below the water surface at its lowest point. Okay, so now its lowest point's 2 feet below the surface. So that means it's going down here to -2. Well then, wait a minute, this is a big wheel. It has a 13-foot diameter. Okay, what were you thinking, Colton? It's going to go up. Okay, now the water is going down like this. Okay, so what do we got to do with that 13 to know how high up it goes? All right, so what is -2 plus 13? Okay, that's one thing we want to do. -2 plus 13 is 11. So we're going to go up to 11. Now I want to get the center line. So I'm going to take -2 plus my max, 11, and divide by 2. Okay, so I was trying to find the distance from the max to the min. All right, now this would be -2 plus 11 is 9, divided by 2 is 4.5. That is your center line, or K value. Center line's at y equals 4.5. Somewhere in here, just make a little tick mark and label it 4.5. I'm not worrying about everything being perfectly to scale, but this is going to be the center line. All right, so let's figure out some other stuff. It revolves 30 times a minute. The frequency is 30 times, but it happens in 1 minute. So how often does one revolution occur? Okay, one time around is going to happen every 2 seconds. Now, wait a minute. If we're going to do it in terms of minutes, though, it's 1/30th of a minute for one cycle. That's the period. Okay, I want you to understand this. So it's happening 30 times in a minute. So whatever the number of times in that amount of time, in 1 minute, it's 1/30th for each cycle. Got it? All right. So let's mark this off as in 1/30th. And I'm not going to do all of the labels, although we could. Half of a 30th would be a 60th. Half of a 60th would be a 1/20th. And then 120, 120, 120. All right, never mind. Don't worry about the label because let's just get a graph. You can do it. what? That'd be 3 1/20th, which is 1/40th. Okay. If you insist on having it labeled. All right, we're not real worried about it for these particular graphs. Now, we want to start where? Oh, it said it started at the top. Okay, so this isn't a sine. It's a cosine. All right, so let's keep graphing it. Go to your midline, center line, back and up. All right, so I'm sketching it. Do we have a question? All right, here we go. Cosine. We got a center line at 4.5. So 4.5 plus, what was our amp? We never wrote that down. Our A value, negative, okay, so 11 minus negative 2 divided by 2 is 13 divided by 2, which is 6.5. You got it. 6.5 cosine. All right, now comes the part that sometimes we make mistakes on more, is what's the B value? So we take the old period, the cosine cycle is a 2 pi cycle normally. It has been completely compressed. We have it 1 to divide by the frequency, which was 1 every 30, 1/30th of a minute. So that's 60 pi. Yeah, 60 pi times x. B is 60 pi. You guys are used to knowing that we're going to multiply by the reciprocal, right? Okay. We're good? Done. At least with that one. I think we just got a few more here. 6. Now we got a Ferris wheel. Oh, why are all these things round? Rotations. All right. Suppose a Ferris wheel has a radius. Oh, radius this time. Max. What's that going to mean? Aaron. Madison, you're thinking. Quit chatting back there. Thank you. Okay, if the radius is 20 feet, all right, what's the diameter? All right, that's going to be the distance between the max and the min. It operates at 3 revolutions per minute. So if it does it 3 times in a minute, then it's happening 1/3 of a minute is 1 cycle. Okay, per cycle. Okay, so now we're going to figure some stuff out. We can take 2 pi divided by the frequency, which is 1/3, 1 out of 3. 1/3 equals, see, 2 pi divided by 1/3 would be 2 pi times 3, so we get 6 pi. That's our B value. But wait, we just said this is per cycle, so 1/3 is actually the period. Okay, so let's go ahead and put 1/3 on our graph on the horizontal axis. Half of that's 1/6, and then we'll make tick marks for half of that, 1/12. 2/12, 3/12 would be 1/4. All right, since that's my x-axis, now I'm going to think about where this thing goes. It says the bottom of the car. So if you think about it, if you're getting on a Ferris wheel, and I don't really have to draw you a picture, but I'm doing it anyways, aren't I? Okay, so if the bottom car, the cars like hang out, and it's saying the bottom car is 4 feet above the ground. So that means we're above here at 4. Now, how high are we going up? Well, it said the radius was 20. So we're actually going 20 in both directions from the center. So it's going to go all the way up to 40 above 4, 44. So here's the more intuitive way of finding out, a few things. What would halfway between there be? Okay, the amplitude we do know is 20. Okay, but what's the K or the center line? No, it's not 20. Okay, so K is actually equal to 44 plus 4 divided by 2, which is 48 divided by 2, or 24. That's your center line. Okay, 24. Think about it. 20 up from 4 is 24. 20 down from 44 is 24. Now, does it make a little sense? Okay, there's our center line. It says, write a model for the height of the person above the ground whose height when t equals 0 is 44. So they're starting here. Yep, it's the cosine. I'll put that in red. All right, back to the center line, down to the min, back to the center line, and up. Okay, up, mid, down, get your graph, and write your equation. Center line's 24 if you like starting with your K value. That can come first. It is starting up, so the amplitude is positive 20. The A value is positive 20. The cosine, amplitude's always positive. The cosine of, do we have the B? Yep, it's 6 pi. We figured that out right in the beginning. Doesn't really matter what order we start figuring things out. But it says to use our equation to predict the height of the rider 90 seconds into the ride. Is our ride in seconds the way we have it labeled? What's then? Okay, so let's convert the 90 seconds to minutes, and then we can pop it in for X. 90 divided by 60 is 1.5 minutes. Okay, so since you have put your calculator into radian mode, you're ready to go. Type her in. I hope. You're going to want to take it out for most everything. So the only, I would go back to degree mode so you don't have any problems with your review and stuff. What is this one? 24 plus 20 times the cosine of 6 pi times 1.5. Did anybody suspect it was 4 already? I had somebody last hour said, well, couldn't you just use the graph to think of that? Huh? 1.5 cycles. Half is at 4. So 1.5 would be back at 4. But that was just a coincidence. It said at 90 seconds. So what if it said 70 seconds? And then he said to me, well, then I'd plug it in. I was like, okay. Right. Okay. All right, one more. Actually, I had to wait on this one in the other class. So I think I'll just do it tomorrow when, well, no, I'm not going to do it tomorrow. We have our quiz tomorrow. Does anybody want to ask me maybe a last minute question before then?